Hello, friends, and welcome to lesson 5 of Unit 3, which is very, very important and very interesting too. And we are going to talk about predictive analytics. If you remember, for the last two lessons, we have been talking about descriptive analytics, diagnostic analytics, and today we are going to predict. That is, we are to forecast something. So, what we are going to cover today: forecast accuracy, linear regression, Facebook case study, machine learning. Now, that is what the main core here, that is the machine learning, and we'll take on hands-on practice with our credit card dataset, which we had been doing for the last two sessions. So let me start. When we talk about forecasting, so when we talk about forecasting something, whether it is continuous or binary, so what is the accuracy? But before that, let me talk about the predictive analytics and where you can apply that. So let me take four examples here. So we can say I want to predict the demand for our product for the next quarter. Another could be, so that is a binary prediction. So what is the predicted gross value for the movie we are launching? So that is again a binary prediction. So of this set of 10 loan applicants, which ones will default? So that is a continuous forecast. So which of these emails is spam? So that is again a continuous predictive analytics that we are going to do. So you know your email box. So once you have identified few emails that these are spam or the sources, after that automatically when the email comes, it goes into that folder. So what is that? That is nothing but predictive analytics. That is a machine learning we are going to talk about. So generally what we do, for example, we talk about the sales forecast, and no one is going to say, okay, the next quarter sales forecast is 6, 7, 8, 9, because it is not going to be true anyway. So what we say is generally, this is a figure we are giving, and it can be plus minus 1000. That is the purpose here. So if I am going to say tomorrow the temperature, maximum temperature will be 34, it may not be 34, it may be plus minus. So that is what we talk about the forecast accuracy. So George Box, who has defined the forecasting, so he said all models are wrong, but some are useful. So we can take a clue from there and we can say all forecasts are wrong. Not all models are wrong. All forecasts are wrong, but some are useful. So let us try to understand the meaning of that. So let me take up the Facebook case study for you. So one aspect of Facebook is that when you go to your page, you open your account of Facebook, what comes first? Which post is on the top? So when Facebook started, it was the latest post on the top. So that was the trend. But slowly what they did, they said, okay, they moved from the most recent to the most relevant. And now they work on the most likely for user to engage with their advertisements. So it is basically, the algorithm is basically built on so that there is a maximum engagement with the client. That means the Facebook user. Now this is a quote I am taking from Facebook. So this is, I have quoted the URL at the bottom. You can go and check machine learning at Facebook. So this is the quote. Machine learning is essential to Facebook. It helps people discover new content and connect with the stories they care the most about. Now, when we are going to talk about predicting the numerical quantities, so we use linear regression, and we talked a bit about linear regression. So for example, we are saying, and you can take as a homework the movies database that we have. So what is the predicted gross revenue for any movie that you're launching? That is one example. The other example, we have been talking from the very beginning about the fancy sunglasses. So what is the predicted willingness to pay for our product among people with income 60,000? So we have changed and we say the people who are having an income of 60,000, right? How much they are willing to pay. So what is that predicted willingness to pay figure? So predicted WTP I'll be using more often as willingness to pay is a number, say 100. And it's not yes, no prediction. So as we have seen, prediction depends on some explanatory variables. Now in this case we are taking income. It can be age, location, occupation, or all. So we talked about the scatter diagram. So what you can infer from the scatter diagram is a linear regression line, which is the best fit as we discussed. So this line is the best fit, and it gives us an equation which is WTP, willingness to pay, is equal to 33.5. That is on the y-axis if you see the intercept. So that is 33.5 plus the slope is 0.0018 income. So that is the best fit line we can get, and that we call as a linear regression line, which you can get from MSSU or ML, the software that we have been using so far. So if we talk about linear regression and I say if the income is 60,000, what is the predicted willingness to pay, WTP? So what I do, I simply put the value in the linear equation that we got, 33.5 plus 0.0018 into 60,000. So it gives me the predicted willingness to pay figure as 141.5 as per this. So now if I want to talk about the accuracy of this, that how accurate the prediction is. So for a point forecast, the accuracy is less. But for example, I say, if you look at the second diagram and you see the red dot, red circle there, so that is what is 141.5 for an income of 60,000. Now here I am not taking care of all the values that you can see in the scatter diagram which fall on that line. So what I can do is I can say there is an interval. So it is not just 141.5, but it can be, let us say, from 100 to 153. So I can say that with 95% confidence that that is the interval which will be of willingness to pay. So I can either forecast the point, that is a figure, or I can forecast a range, which is the interval. So point forecast and interval forecast. So of course, but obvious that for internal forecast, you will be able to include, in this case, as you can see in the scatter diagram, 95% of the values which fall in that particular bracket of your income. So as we go towards the edges, right? So then, and I extrapolate, so my interval goes bigger and bigger. And if I want to keep the same accuracy level, same confidence level, then that means then it is going to be, it becomes more random. And you will have, as you can see, the tightness which is towards the mean, right, towards the center. So in a way, I can say with 95% confidence that the people having 60,000 as their income are willing to pay in a range of 141.5 plus minus 45. So that is how we will be able to do. As we go further away, and as per the scatter diagram and the best fit line, you will see many values, and when you extrapolate, this range increases. So another good thing is to, if I am forecasting, for example, the sales. right? So one is I'm using this time series forecasting along with the linear regression. So here I must consider the time series. That means what if there is a 10% growth trend from the historical data. So I should include that 10% on top of this. Right? So for example, if my forecasted sales figure is say 141.5, so I'll include 10% growth trend in that, and then I'll put the interval there. So you need to consider that also. So let's talk about machine learning. How do you predict? How do you forecast? Let us take firstly two examples how we use the machine learning. You know your spam email, so your Google or Gmail e-services, they use machine learning. So they can see which are the spam mails, and through the machine learning over the years, what is spam for you, they put the spam mails in the spam folder. Similarly, based on the past record of your clients or the past background of different clients, a new customer comes and wants to take loan from the bank. So based on the parameters on which you are looking at giving the grant, and you want to check the default, whether they are going to default or not. So you can predict whether you should be giving the loan to that person or not for the new customer or for existing customer. So that is all about the machine learning. So these are the two simple examples I can quote, and there are n number of examples. Now let us do that hands-on how we can use it. Here is your credit card data set which we have been using. So now please understand two things here. So we are going to use not all the fields here. We will be using just 5 fields out of this. But 2 fields you must understand correctly. So number 1 is pay 1. So you have gender, education, marital status, age, and then pay 1 to pay 6. What is pay 1 to pay 6? And we'll be just picking one field here, which is pay 1. Pay 1 is whether the person has paid the due amount, right? So if there is a due amount for the last month, whether the person has paid that due amount, so the value of pay 1 will be 1 or 0. So if the person has defaulted, right, that means has not paid in the first month. Has he paid after 1 month? So if he has paid in the first month, the value will be 1. If he has paid in the second month, the value is 2. If he has defaulted in the first 2 months and paid in the third month, so value will be 3. So pay 1 is when he has paid that. So it will be from 1 to 6. So this is for the last 6 months we are recording that. So the bill amount is for the month 1, and for that pay 1 whether he has paid in the first month, so or in the second or third, but bill amount and pay 1, they are interconnected. So try to understand. And default is whether he has paid. If he has paid, then it is 0. If he has not paid, he has defaulted, it is 1. Right? So it is very important, and this is the dependent. So we'll be doing our machine learning on this default field. So that becomes our dependent variable. Now question is, what is machine learning? Machine learning is that we learn from data, and so that we learn from the existing historical data, and then we can, based on that learning, we predict the future. So which emails are spam? So firstly we need to understand which are the emails for me which are spam. So which bank transactions are fraudulent? We need to associate the properties towards that from the existing data. If a customer bought some products at a website, what other products should we recommend? Right? So these are all examples of machine learning. So let us now try to build this model. Also, when we talk about machine learning, there are 2 types of machine learnings. One is supervised and one is unsupervised. So in case of supervised, we have some data which is already existing, and we know that on that data what are the results. So if I have data and people have defaulted, so what I do is I try to learn if they have defaulted, and I know they have defaulted. So I have that data, and then I can check against whether after learning whether the predictions I'm making for that existing data is matching with the existing results or not. So after that, we train the model, right, algorithm or the model on this data. Then we test the algorithm with a different data set to see the performance, and then we use that model for predicting the future. So in this, what we do is, if we have only one data set, we can split the data set as we are going to do today into two sets. One will be the training set and one will be the test set. For example, if we have 30,000 data, right? So we can use 70% of that data, which is around 21,000, which we'll be using for our training purpose. And then 9,000 data, which we have is, we'll be trying to test on that 9,000. So 70-30 we can split. Unsupervised machine learning is where we don't have that existing data. For example, in case of elections, and there are millions of voters, and I don't have any past data about those voters in the current scenario, for example. So in that case, what we can do is we can pick the demographics of that data, and then we can classify them into different groups, and that is what during the elections like these are coming in US in November. So this is what they will be doing. So they look at the demographics, they divide them into some natural groups, and then they have their campaign strategies for each particular group. So the algorithm that they build, they will do the analysis and suggest who all can fall in which group depending on the training that you give to the model. So in our case, let's now start. We have understood, and we are going to use the supervised machine learning. And for that, what we do is we pick our data set, and since you have saved that, you bring that to your Azure ML canvas, which I call. And then what you do is you, from that database, you use select columns, as you can see on top here. So in the search box, you put select columns. So there are different ways. So we are using learning a new tool today. So I put select columns, and then I pick 5 fields, 5 columns. One is default, limit balance, age, marital status, and P1. So we pick that, we select these 5, right? And after we have imported the database, or we have picked the saved database, which is the credit card. And then I said select columns, and I drag it under that, and I then selected the 5 columns that I need. After selecting, as you can see, importing or save database, whichever you want, you drag the select columns, and then you put the 5 columns here, and then after that you type in here split data. So as we said, we'll use this database 70% for testing and 30%, so 70% for training and 30% for testing. So I say split data, I bring it here, and in this, what I fraction of rows and this I say 70%, so 0.7. So I put 0.7 on the properties box under fraction of rows, right? And then I also tick randomized split. So I will pick 70% data which is random, which is not in the sequence, right? So I can use stratified split also, but I will be using the randomized split in this case. And after that, what I do is, the next step is I pick a decision forest. So I type in the search box to class decision forest. So there are different models that you can pick from the machine learning. So it is out of the scope of this lesson where I can talk about all of these decision models. But let us use, and I'll talk about this, why we have picked this. So two-class decision forest, so we'll be talking a little more about this model. And I type in the search box, and then I drag it to the left of split data, to the left of split data. So once I bring it there, then in the properties, I need to change two things. One is the decision tree, the number of decision trees, how many trees you want. So to keep it simple, I'll have one tree. So I can have any number of trees, which becomes very, very complex. So we keep it one decision tree, and each tree will have 4 levels. So there is one tree, and it will go, the maximum depth of the decision tree is 4. So I decide one tree with depth as 4. So I do this, and then I have split the data to the left. I have taken two-class decision forest, and then what I do is I have my test model, train model. And so what I do is I write here train model in the search box on the left. In the second diagram, as you can see, I type in train model. I have train model. I drag the train model. Below the split data and the decision forest. So below the two boxes, I drag my train model, as you can see here. And train model has two circles on top. The left circle I connect with the two-class decision forest, and the right small circle I connect with the split data. So this is how I connect them. So what I am doing here, try to understand. So split data, in the split data, I have 70% data which I want to train my model with. So that 70% data will be going to the train model. Okay, and also I want to use the model which is two-class decision forest, which is going into this train model. So for the train model, I need two inputs. One is which model I'm going to use, and second, what is the data with which I want to train the model, which is 70% of my credit card randomly picked from the data set. So what next? Then I will pick, I go to the top left search box and I type in score model. I type in score model and I drag it, score model, I drag it below my test model. So I drag it below my test model, and then it needs two inputs. One input, so this is score model. That means this is the model which I have trained. So this is my trained model. This is the model which has been trained with the test model. So one is I want to have this trained model after I tested the model. So it is 1. So this is my tested model which is going to the trained model. So this model is going to give me some final values, and the 30% of the data from the split data. So remember, 70% is going to the test model and 30% is going to the score model. Score model is, it is going to predict. So this model is going to predict. So I need two things. What is the model which I have built, which is the test model, and second is the 30% data which I want to predict. So once I have done that, what next? Then I say evaluate model. So I go back to the search box and I type here evaluate model, and I drag it, evaluate model, and drag it below my score model. So I have this evaluate model at the bottom, and then I connect that with the score model. For the score model and the evaluate model, you don't have to give any properties. Okay, once you have done that, what is the next step is you run it. After you have run it without any errors, so I go to my train model. I go to my train model and I go to my train model and I go to visualize. I right click and I go to train model and I go to visualize. So once I visualize, what I get is this train model. So this is the model which has come out after my training. So this is my trained model which I have trained. Okay, similarly, when I click on evaluate model, I right click and I see, and then the final one, the visual one. So I right click and I get the results. So similarly, I go to the score model. I go to the score model and I say, I right click on that, I visualize, and I see the evaluation results. So when I click on that, I get this ROC curve. So this is what I'm seeing: evaluate model and evaluation results. So right clicking on that, visualizing, and then evaluate model and evaluation results. I get ROC. So we'll talk about what is ROC. This curve you want. And the other thing is, if you go below this, if you go scroll down a little bit, you get this table. And we call this as a confusion matrix. So we'll understand what is this confusion matrix and what is this ROC. So you see ROC on top. If you scroll down, you get this. So we need these two. So we'll talk about that. So firstly, let's talk about the trained model when you visualized it. So this is what you get. So once you are on this, what you do is at the bottom you get edges. So if you look at this diagram at the bottom, edges is clicked, blue tick. So you tick it, so edges. Edges will give you true and false. So what you are looking at this trained model is, it has built a decision model for you. So it is firstly is pay 1. So any 30% of the data for which we would like to predict. So any value it picks the value of pay 1 from the database, and it checks whether it is less than equal to 1, whether the person is paid in the very first month. If it is true, it will take this path. If it is false, it will take this path. So for example, in this particular one record that we are checking, it is false. Right, so it is greater than that. So he has not paid in the first month. So limit balance is less than this. If it is yes, it will go to the true path, so it has taken that. If the age is less than equal to 55, it is true. Sorry, it is false. It takes this path. If it takes this path, so the likelihood of this person is that he will not default. And what is the probability? It is 67%. Similarly for different, so they have shown this. So what is the probability? That is the percentage. Whether they will default? Yes, they will default. Default, default, not default, 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 not default. So from left to right, 0 means default, not default, sorry. And this is the probability below, which may be 83, 87, so values may differ. So 1 is default, second circle at the fourth level at the bottom, 1 is default value. So like this, you can understand this. So that is the prediction. Right? So this is the test trained model that you have built. So when I go to the next one, when you go to the next one, what you see here is the scored labels and probabilities. So this is, you go to the score test. So in the score test, when you say visualize and you see this scored labels and probabilities, so how to see this? Now in this, for the 30%, that is the 9,000 rows, that is the 30% of the split data for which you are going to predict. So you see the first row here, it is 50,000, limit balance, education is master's, age is 29, pay 1 is 2, right, and default is 1. So that means the value default, which is already available with us, he has defaulted. Okay, and what is the prediction? Score label is the predicted one and default is the actual one. So what we have predicted is 1, and actually also it is 1, so our prediction is right. So second row is, it is 0 and it is also 0, not defaulting. So like this we can check. Now you look at 3,000, 30,001, right, which I have put as a circle here. Here the predicted value is 0 in the third red circle I am referring to. So the predicted score label is 0, whereas actual is, default is 1. So this is an incorrect prediction where we have predicted this person is not going to default, but he has actually defaulted. So this gives you that. And what is the probability? Like in the first case, the probability is 0.7. That this person is going to default, the probability is 0.7. The second row is this person is not going to default, the probability is 0.16. So source code probabilities, how good we are in predicting that. Now it is very important to understand that matrix which we talked about, which we call as a classification, or sometimes we call that as a confusion matrix also. So when we talk about classification or confusion matrix, we need to look at these four values. So this is a true positive. What is true positive? That means the person has defaulted, right? And our prediction is true, right? Another one is false positive. Another one is false positive. What that means is that the person is not going to default, right? And but he has defaulted. But he has defaulted. So false means our prediction is that he is not going to default, but he has actually defaulted. So in the true positive, actual is 1 and predicted is 1. So predicted positive means he's going to default and actual is also 1. Whereas when we talk about the false positive, just below that, false positive where I put the circle. So what that means is that the actual value, he is not going to default, but we are saying that he has defaulted. So that is false positive. Now here if I talk about the value which is the accuracy, if you look, the accuracy is 0.823, that is around 82%. The accuracy is 82%. How do you calculate that? So in this, the true predictions that you have made is true positive. That means what you have said is the actual value is the person is going to default and the person has defaulted. So negative, true negative is the person is going to not default and it is negative. That means your prediction is also negative. So 0, 0, right? So this is 1, 1, this is 0, 0. So if 1, 1 and 0, 0, these are the true predictions. So what is my accuracy? 666 plus 6738. So all defaulters, all good predictions, no defaulters, all right predictions, adding these two, and these are wrong, right? So then 666 plus 6738 and divided by all the four values. So this is my accuracy of prediction, where I have predicted that 666 are the people who are going to default and they have actually defaulted, and there are 6738 people whom I have predicted they will not default and they have not actually defaulted. Whereas here false positive, that means I've said 271 will default but they have not actually defaulted, and 1325 are those where I have said they are not going to default but they have actually defaulted. Okay, so this is what you mean by accuracy 82%. Now let us also talk about precision. There are two more things here. One is precision and one is recall. So let me talk about precision, which I have circled here. What is precision? Precision is that there are true positive and there are false positive. Okay, so there are 666 people who have defaulted and I have been able to catch them. But there are also 271, try to understand this carefully. There are 271 more people who have defaulted, but I have not caught them. I have not predicted them. So what are false positives? False positives are those people who have defaulted, but I have not predicted them. So what is my precision of the people who have defaulted? So I'm just talking about the people who have defaulted. So out of 666 plus 271, which is, let us say, around 1000, I have been able to catch only 666 people who have defaulted. So my precision becomes 71%, 0.711. So another thing is the recall. Let us understand what is recall. Recall is that there are 666 people whom I have been able to catch, and they have defaulted and I have predicted correctly. Now there are people who have not defaulted, but I have said that they are going to default. Okay, they have not defaulted, but I have said that they will be defaulting. So what is the value? 666 divided by 666 plus 1325. So that is the recall value. So that is around 33.5, 33%. Okay. Now these 33%, now that means uh, in this I have a precision of 71%. So out of 666 which I have got a precision of 71%. Okay, and 29% chance even in 666 that I may fault, because my precision is 71%. So when I talk about accuracy, which is 82%, so that is not a good indicator, because 82% I'll feel that it's very good, right? If I talk of financial transactions and I'm talking of a bank, so what comes is most important part is false negative. And what is false negative? That means I said that they will not default, but they have defaulted. That means 1325, 1325 out of 9000 have not been able to find. And they are the defaulters, but I have not been able to find those. And if I want to increase this precision, this accuracy, I need to work on that. So that could be very costly to the company, right? So this is how you interpret the metrics, and that is why it is known as confusion matrix. You need to understand that more carefully. And when we talk about ROC, what is ROC? ROC is the receiver operating characteristic. So this curve gives you that how good is your model, whether you can bank on this model to be used or not. Because if the model is not good, it may give not very good predictions, and maybe it would be better if I use my wisdom rather than using this model. So how to interpret this ROC curve? In the ROC curve, you draw between true positive and false positive, right? So true positive and false positive. So the true positive, I take the highest scores. That is where the probability is very high. That I take first. So I align my data in such a way, um, and I draw this curve with the highest scores first, with the highest probability. Okay, so I draw this graph, and after that, if you look at this curve, so if I take the first circle as you go on the blue curve, I'm talking of the blue curve, and you see the first, as you go along the curve, blue curve, you saw the first red circle. So that is the point which I'm saying is 30% is the true positive. So where I have predicted that they will default and they have defaulted. So here it is 30% rate. And uh, the false positive is around 3%. So that means I'm able to predict with 30% accuracy and 3% where I am unable to find. So that's very nice, that's very good. But as you go up, as you can see, this goes down. The true positives, their percentage goes down. For example, if I say I go to say zero point 0.7, right? I go to zero point 0.7, so it is around 0.4. Around 40% of the people are unable to catch, which are false positives, who have defaulted, but I have not been able to predict that. So what is the right model? So my perfect curve would be vertical one, right, which you see going vertical up and then going to the right like the corner of a rectangle. So that is the best, because here I have the very less false positives and very high true positive. But if it is 45-degree line, linear line, as you can see, so that is completely random. That is like flipping a coin and saying if it is heads, he will default, if it is tail, he will not default. So I may not use this model. So I can improve upon this model, and I can take it further towards the left. As you can see, it becomes a perfect model towards perfect model. And how I can improve the model is at this stage I'll say two things. One is the depth and the levels. So I can, that is why I call that as a forest test. So like in a forest you can have many trees. So we are taking one tree, right? So you can have more trees, and the depth I have taken as 4, you can take 8. As you increase that, your precision and accuracy increases. Second is the threshold. What does that mean? So when I say in my prediction model that these people will default, right, as the true positive, so the threshold I have taken is 0.5, 50%. That means when the probability is 50% or more, right, then I'll take that as the person will default. So threshold, we can show you in the software. If you increase, the values change. So you can increase the threshold or decrease the threshold. You can say the probability I'm looking at 40% only. So will you be able to catch all? It depends whether what sort of prediction you want to do. So all these things, so that is what is machine learning that we have discussed. So let me summarize the things for you. So number one, we talked about forecast accuracy, then we talked about linear regression, then we took a case study on Facebook, then we looked at the machine learning and we did a practical hands-on exercise on the credit card dataset. Then we looked at two important interpretation indicators in the model, machine learning. One was the conversion or the confusion matrix, and the other was the ROC curve. Here is a small quiz for you. So you have to tell me which has more accuracy, point forecast or the interval forecast. Second one is which machine learning we used in our credit card example, supervised or unsupervised. And the third is what is more important in machine learning optimization, precision recall or false negatives with respect to the credit card example, which is a financial thing. So you can check your answers if you have noted down. Interval forecast has more accuracy, and we use the supervised model under the machine learning for the credit card example. And false negatives are more important, because if you can't catch hold of the people who are defaulting, right, then that's a area of worry in the banking sector. So that is all from my side. If you have any questions, feel free to write to me. And if you want to go for some further reading, these are the two articles I suggest. One is Predictive Analytics, which is transforming data into future insights. And second is that where predictive analytics can make a big impact in times to come. So thank you very much. See you with the next lesson soon. Bye for now. Shabba khair.